Good afternoon, everyone. Welcome to my presentation. And today my topic is the effect of vitamin A deficiency on pupillary light reflex of Japanese black cattle. I'm Han, and the second year of doctor course. And this is the outline of today's presentation. First, in background, I will introduce the vitamin A deficiency may cause the change of pupillary light reflex. And my objective is to investigate the relation between vitamin A level and pupillary light reflex. The device now we are using is the 2CCD camera, and the method is investigate the effect of vitamin A deficiency on pupillary light reflex of Japanese black cattle. And last, I will introduce results and conclusion discussion. First, please look at the three beef images. If you visit the supermarket in Japan, you will find that the rightmost is the most expensive one. According to the Japanese beef grading standard, that the beef which contained well-distributed intramuscular fat, also called marbling score, is the best beef, best quality. So there are many researches conducted that have shown that lower vitamin A level group can produce higher marbling score beef. So beef quality can be increased by controlling serum vitamin A of cattle at the lower level, especially during the fattening age. So to produce higher marbling score beef, Japanese farmers already adopted a policy that, like this one showed, they will control the serum vitamin A level during the mid-fattening age, means from 16 months old to 26 months old, at a critical lower level, around 30 international unit DL. However, if this vitamin A level dropped too much, it will bring higher possibility that the cattle will get this kind of diseases like night blindness, diarrhea, and others. So it is important to monitor the serum vitamin A level. The traditional way is by blood assay, and it's accurate, but it's not available for all the farmers and for all the cattle. It's time-consuming, expensive, and stressful to the cattle. So we want to find some other alternative that can estimate the vitamin A level. Some research showed a potential to estimate vitamin A level by analysis of pupillary light reflex. This graph showed Matsuda-san conducted this research. This is the shrinking time, and this is the vitamin A level. This graph shows that the lower vitamin A level group usually takes longer time to shrink. Another research, this is Japanese, and the red line indicates the lower vitamin A level group. The blue is higher level vitamin A group. And so the lower vitamin A group takes longer time for shrinking. But different from them, our research is only focused in 1 second. Their research is about more than 10 seconds, because we want to install some automatic detection system, so it is impossible to keep the cattle such a long time. Maybe just 1 second is available. So the hypothesis is vitamin A deficiency would introduce defect in optic nerve of cattle. When vitamin A level becomes lower, the cattle's eye become less sensitive to light. Here I will show this is shrinking in 1 second. Actually, this is 3 seconds to make it clear. I extend the time. Our objective to investigate the relation between vitamin A level and pupillary light reflex. and ultimately maybe estimate vitamin A level by pupillate reflex or cattle's eye. Our tested animal is Japanese black cattle. In this presentation, I showed 10 cattle's result. And the cattle's age at the beginning of this experiment is 15 months old. And we conducted for 1 year, from last year this time, maybe. Hyogo Prefecture. They are in the middle fattening age. Their vitamin A level is like this. This is the device now we are using. The right side is a 260 camera. It can enable us to take both color image and near-infrared image. In the center, there are two kinds of light source. One is near-infrared LED and a white LED. This shows the actual appearance. And in front, there is a tube, and this part connected to the cattle. In front of the lens, there is a PL filter to reduce the higher reflection of the strong white LED light. This is our experimental schedule. First, fix the cattle's position, and then cover the cattle's eye by black cloth, and then wait 2 minutes, and then put the camera in front of the cattle's eye, and then adjust the camera position by checking the near-infrared image. At this time, the pupil will not shrink because near-infrared light is not sensitive to cattle. And then turn on the white LED light and take pupillate reflex image. This graph shows the actual image we take. Well, this is the near-infrared image, this is the color image. And we conducted the banalization in HSI color space, means hue, saturation, and intensity. Just after banalization, the result is like this. And then we do some noise reduction and fill the center LED ring. And last, we count the pixel number in the pupil area. Then let's take a look at the result. And I will analyze the result in following aspect. First, please, the green line, the green curve shows normalize the pupil area. This is the time in 1 second. So, and first, it will not shrink, maybe a little enlarged, and then begin shrinking until 1 second. The blue line is the first derivative of the pupil area. It can be represented the velocity, and the right line is acceleration, the second derivative. I expect first, this is the first factor is the maximum velocity, and then amplitude, and then amplitude means after 1 second, and then the time of the maximum velocity happened time. The last is acceleration, sum of acceleration. I choose this kind of factor because I think it is easy to understand and maybe related to the cattle's status. This is the phoneme, maximum pupil constriction velocity, and the pupil constriction amplitude in 1 second, and the time of maximum pupil constriction velocity, and sum of pupil constriction acceleration of the first 0.2 seconds. But previously I showed 1 cattle shrinking, but in our experiment, the 10 cattle in some months, 1 cattle lost the shrinking. So after the light on, the pupil area didn't change much. I think this is caused by maybe advanced vitamin A deficiency. And so then I will show the result from the previous. I introduced the 4 factors. the left side is the cattle that I showed, that I just showed lost of absence of the pupillate reflex. The right side is all the 10 cattle's 1 year's data, and this is the maximum constriction velocity. Actually, there is not so clear tendency relation between the vitamin A level and the maximum constriction velocity. The video shows this cattle's March data. So in March, it can be seen that the maximum velocity is very low, corresponding to the population that it represents at this point, compared to others. This has a lower velocity. Also, by this scatter plot, maybe we can't see any relation between vitamin A level and the velocity. This is the constriction amplitude of this cattle and all the cattle. Also, not so, not a clear tendency or something. And March data corresponding to this data in the whole population. The same thing happened in so there are 4 factors. I think the vitamin A level and the pupillate reflex factors, there is no clear relation. This is this point, and this is this corresponding to this point. And so this is the conclusion. The result indicate it is impossible to estimate the serum vitamin A level in Japanese black cattle by analysis of pupillate reflex. However, it is possible to detect the cattle who lost the pupillate reflex, which may indicate the vitamin A deficiency. The cattle with weak pupillate reflex showed a smaller constriction velocity and a smaller amplitude, and a longer shrinking time and a smaller acceleration. Discussion. The advanced vitamin A deficiency can cause the retinal degeneration. However, the retinal degeneration is not supposed to affect the pupillary light reflex. Also, in the healthy cattle, the pupillary light reflex has a wide range, so also can be affected by the emotion status of the cattle, like fear, anger, and excitement. During our experiment, maybe the cattle is not in the same motion, so it is difficult to predict the vitamin A level. That's all. Thank you.
Okay. Your second last slide, can you think? Second last slide, can you show me? So, can you explain to me the difference between the first conclusion and the second conclusion?
So, and first, I want to make up a machine vision monitoring system that can predict all the cattle's vitamin A level. But it seems the result showed it's very difficult, because even some cattle has a very higher vitamin A level, their pupillate reflex is lost. So I think it is impossible to estimate the vitamin A level. But I think that I can detect the cattle who lost the pupillary light reflex. So maybe related to vitamin A deficiency. or maybe not. But this is not, I'm not sure of that.
So if I put it in other words, you cannot measure the absolute amount of vitamin A,
Yes.
but you can measure the relative change. And the relative change does indicate vitamin A deficiency.
I think so.
I think this is related to philosophy. Is it, you mean that the first one you try to say that for quantitative study, so it is impossible to calculate vitamin A level by using analysis of pH. But qualitatively, you can classify which one the cattle who lost PLR or who not lost PLR by using who lost vitamin A by using PLR. So the first one may be related to one study, and the second one related to qualitative study. Some you can classify this is cattle with vitamin A deficiency, and this is not.
Yes.
But you cannot calculate the amount of vitamin A level by using your equation or your analysis.
Yes,
So I think maybe
because vitamin A also storage in the cattle's body, so it is very difficult to predict the actual level. So it fluctuates. So maybe the pupillary reflex is just an indicator of how long this cattle suffer from the vitamin A deficiency.
so. I just suggest you that your study is still useful to. Yes, we need also to classify. We don't need to know the amount of the efficiency of the amount of vitamin A level, but we need to know that when the cattle start to has deficiency of vitamin A, and so if we know such kind of sensor, so we can classify. Okay, this is still okay, still safe to apply loss of vitamin, not filled by supplement of vitamin A, but still safe, not deficiency. But if we find that yes, only we get deficiency, so we stop and we try to start feeding by supplement of vitamin A. Okay, so the study has a possibility to apply such kind of area to classify. I think.
Okay, thank you.
Anyone else? Would you show us the result again? Acceleration. Not so bad. Not so bad.
But actually, this kind of data, there is no, I think, no tendency when vitamin get lower.
Before this, one more. One more. Something. Yeah, only this 3 years something strange, but if just up forward, it's quite good, too good.
Maybe some mistake in the calculation. You have to check.
And it has something this tendency. No?
I think
The point is, we don't expect each individual result has a much relation with vitamin A. We would like to have, get some, what kind of, even if it has a 0.1 correlation, would be, multi-variable analyzing method makes very good result. Would be good result, I think. I hope you continue to analyze this.
Yes, I will continue.
So, but your conclusion said the impossible. That is too strong. Maybe, we may be able to find something. Don't give up so early.
Maybe I should add some impossible to measure accurately.
Very impossible.
One more thing, you showed the another graph. One more. This normalized pupil area. This could be almost saturated here. So 1 second is enough to analyze this pupil area. You think?
Actually, still shrinking, but this data I already used some smoothing method to make it better. I think maybe 2 seconds is enough to
this
stop
is
shrinking.
already saturating. So that means this can connect to the Matsuda-san's previous result.
I think.
Sorry. 1 second enough or not? Matsuda-san. Yeah. This shrink percentage. Would you make bigger? Saturating around here, 3 seconds, or even longer. Ours just 1 second.
Yes, ours
That is
only
fine.
1 second, but our the percentage is about 70. Same.
How do we connect? Ours just 1 second. This analysis. This analysis is ours.
Yes.
Masa-san is after this. Maybe which is better? We can find which is better later.
Now we only have data of 3 seconds, but I only used the 1 second. We have 3 seconds information data.
3 seconds. But hopefully shorter is better.
Shorter.
Shorter is better. Quickly we'd like to know that by predicting the prediction of the binding A. So, I hope you can find something.
Also in that graph there, if you look at 90% saturation, the high vitamin I gets to that in a very short time, whereas the 90% saturation for the low vitamin is quite order of 2 or 3 larger. So time to saturation, well, 100% saturation will take a long time. But if you take, for instance, 90% saturation, time to then there is quite significant differences between the 2 groups.
I see.
So lower vitamin A cathode needs longer. Higher vitamin A cathode, shorter, quickly.
Yes, I think this data may indicate the same result, because the much data is lower vitamin A and no shrinking, but the maximum velocity happened time is much lower, or about 1 second. sorry. This term indicates this point. So the lower shrinking, the peak is here, around 1 second. Others about 0.5 seconds. I mean, this cattle is vitamin A deficiency cattle. So
we expect the good findings among these. I think it's time to stop. Thank you very much.